friends, welcome to Rashmi's classes. Today we'll discuss on IP throughput in LTE, its formula, factor affecting it and how could we improve IP throughput. So let's get started. The IP throughput in LTE is the amount of data that can be transferred over the network in a given period of time, typically measured in bits per second, BPS, or megabits per second, MBPs. The calculation of IP throughput in LTE is based on the following factors. 1. The physical layer data rate, which depends on the modulation encoding scheme, MCS, and the number of resource blocks, RBs, allocated for the transmission. 2. The packet size, which determines the amount of data that can be transmitted in a single packet. 3. The packet loss rate, which is the percentage of packets that are lost or discarded during transmission. The formula for calculating IP throughput in LTE is IP throughput, MBPs, equals packet size in bits * number of packets sent, time taken, in seconds, 1 million. Where the packet size is in bits, the number of packets sent is the total number of IP packets transmitted during the measurement period, and the time taken is the duration of the measurement period in seconds. It's important to note that the actual IP throughput may be lower than the calculated value due to various factors such as interference, network congestion, and protocol overhead. Therefore, the calculated IP throughput should be considered as an estimate rather than an exact value. There are several factors that can impact IP throughput in LTE, including 1. Channel conditions. The quality of the radio channel can have a significant impact on IP throughput. The presence of noise, interference, and fading can cause errors and reduce the effective data rate. 2. Modulation encoding scheme, MCS. The MCS determines the number of bits that can be transmitted per symbol and the level of error correction. A higher MCS can increase the data rate, but it may also be more susceptible to errors. 3. Bandwidth. The available bandwidth is a key factor in determining the maximum data rate that can be achieved. A wider bandwidth can support a higher data rate, but it may also increase interference and reduce network capacity. 4. Number of antennas. The use of multiple antennas, also known as MIMO, can improve the signal quality and increase the data rate. However, it requires additional processing power and may not be practical in all scenarios. 5. Traffic load. The amount of traffic on the network can affect IP throughput, especially during peak hours or in congested areas. High traffic levels can reduce the available bandwidth and increase delays and packet loss. 6. Protocol overhead. The use of protocols such as TCP, IP can introduce overhead that reduces the effective data rate. The overhead can include packet headers, acknowledgements, and other control information. 7. Network architecture. The network architecture, including the number and placement of base stations, can impact IP throughput. A well-designed network can minimize interference and optimize the use of available resources. 8. Cores, quality of service, settings. The core settings can prioritize certain types of traffic over others, which can impact IP throughput. For example, real-time applications such as video streaming may require higher priority to ensure a smooth user experience. 9. Interference. Interference from other wireless devices, such as Wi-Fi or Bluetooth, can impact IP throughput. Interference can cause errors and reduce the effective data rate. 10. User device characteristics. The type and capabilities of the user device can impact IP throughput. For example, older devices may not support the latest LTE features, and devices with weaker antennas may have lower signal quality and data rates. Now there are several ways also to improve IP throughput by changing parameters with examples. 1. Increase the maximum modulation scheme. By increasing the maximum modulation scheme, the LTE network can transmit more data per symbol, which can improve IP throughput. For example, the parameter max modulation scheme can be increased from its default value of 64 QAM to 256 QAM. 2. Increase the size of the transport block. By increasing the size of the transport block, the LTE network can transmit more data per transmission, which can improve IP throughput. For example, the parameter max TB size can be increased from its default value of 4096 bits to 8192 bits. 3. Enable carrier aggregation. By enabling carrier aggregation, the LTE network can combine multiple carriers to increase the available bandwidth and improve IP throughput. For example, the parameter CA enabled can be set to true to enable carrier aggregation. 4. Increase the number of supported RBs, resource blocks. By increasing the maximum number of supported RBs, the LTE network can accommodate more users and transmit more data at once. For example, the parameter max num of RBs can be increased from its default value of 100 to a higher value such as 200. 5. Enable MIMO, multiple input multiple output. By enabling MIMO, the LTE network can use multiple antennas to transmit and receive more data at once, which can improve IP throughput. For example, the parameter MIMO enabled can be set to true to enable MIMO. 6. Increase the T transmission time interval. By increasing the T, the LTE network can transmit more data per transmission, which can improve IP throughput. For example, the parameter T can be increased from its default value of 1 millisecond to 2 milliseconds. 7. Enable dynamic TDD, time division duplexing. By enabling dynamic TDD, the LTE network can adjust the uplink and downlink time slots based on traffic conditions, which can improve IP throughput. For example, the parameter dynamic TDD enabled can be set to true to enable dynamic TDD. 8. Increase the HARQ, hybrid automatic repeat request, retransmission count. By increasing the number of HARQ retransmissions, the LTE network can improve the reliability of the data transmission, which can improve IP throughput. For example, the parameter max HARQ RTX can be increased from its default value of 3 to 4. 9. Increase the maximum transmission power. By increasing the maximum transmission power, the LTE network can transmit data over longer distances and through obstacles, which can improve IP throughput. For example, the parameter max TX power can be increased from its default value of 23 dBm to 30 dBm. 10. Enable semi-persistent scheduling. By enabling semi-persistent scheduling, the LTE network can schedule periodic data transmissions, which can improve IP throughput. For example, the parameter SPS enabled can be set to true to enable semi-persistent scheduling.